Hey there, 205. We are starting a unit on sampling today. There's going to be 3 videos. And I have decided to try to make the videos a bit more fun. So at the end of every video, we will end with something called One Fun Thing, where I will tell you something ridiculous or do something fun to entertain you guys during this time, because I know that this last week in the United States has been pretty devastating, and there's going to be some more devastation in the near future. So I'm going to do one fun thing at the end of this video. That's your reward for getting through the whole thing. Okay, so in class, we have finished research designs. We are done with them. We are done talking about how they are set up. So now we can go to the last stage of the sort of overall research conducting process. This is technically part of the design that we're about to talk about, but we're done with the actual setups. Before we get into it, I want to start off with a little anecdote. So back in the 1930s, there was a publication called Literary Digest. This is a very well-known story. And Literary Digest used to do a poll to predict the winner of the presidential election every 4 years. This was a famous poll that they did. And they had gotten this right like 4 times in a row. So the 1936 election is approaching, and the Literary Digest magazine comes out with their prediction, and they say Alf Landon is going to win the presidency of the United States. Now, I want you guys to ask yourself honestly if you've ever heard of the name Alf Landon before. I'm pretty sure the answer is no. Every time I ask this to my students, nobody knows who this is. Well, that's because he didn't win and he never became president. Instead, FDR won re-election, and the map looked like this. It was one of the craziest blowouts in presidential election history. So the question is, why did Literary Digest get this so stunningly wrong? Okay, usually I prod the class to figure this out, but what happened was they were doing bad sampling, okay? They were sending their survey out to their own subscriber list, as well as a list of people who subscribed to a magazine about cars, which means that they owned cars. Let's think that through. If you are subscribing to a magazine in the 1930s during the Great Depression, that means that you have disposable income. The vast majority of people during the Great Depression do not have disposable income. There's 30% unemployment. It's horrible. So the people that they are asking who you are going to vote for in the next election to make their prediction are disproportionately wealthy people. They can afford a magazine at that time. So this is really bad sampling, and it led them to make a bad inference from that sample. This is a very famous study, or a very famous situation, rather. Okay, so this is a problem of sampling. Let's talk about what sampling is, because some of you will have to use this for your final paper. Let's define some words first. The first word that we have to know is the word population. The population is the entire set of entities that are under study. This is the group that you are going to try to make inferences about. Obviously, guys, I still have my iced coffee, even though I'm at home lecturing you from my house. So the population is the entire group that you're making inferences about. Then what is the sample? The sample is a subset of that population. So we're going to use the subset of that larger population to try to draw inferences about the whole population. Okay, in fact, that is the goal of quantitative political science research, to draw inferences. Based on something that we test in a sample, we're going to try to make statements about a much larger population on the whole. So think about it this way. You guys have seen the Gallup poll probably many times at this point. I've talked about it before. When Gallup tries to do the presidential approval ratings, do you think that they are calling up every single person in America to ask them how much they approve of the president? Of course not. That would be impossible. They're calling up a sample of the population that is representative of the whole population, and they're taking that sample and they're making inferences from it. You've probably never been called for that Gallup poll. I've never been called for that Gallup poll. Lots of people haven't been called, but some people are called, and they believe that those people, usually they're randomly chosen, can represent the whole population. So that's what Gallup is pretty much doing. That's their sampling. Okay, so I'm a visual person. If you want to think about it this way, think about it this way. You have your entire population. We pull out a small group of them using some sort of sampling framework, and that small sample is going to represent the whole population. Each person in the sample, or each thing in the sample, we call that a unit. Okay. The 3 steps to figuring out sampling. The first is you define your population. Are you making inferences about the entire United States? Are you making inferences about South Carolina residents? Are you making inferences about every speech given by a president ever? These are your populations, and you have to know what they are, and you have to define them. Who or what are you trying to make statements about overall? Step 2, figure out if you can use the whole population. This should send off signals. If you don't have to sample from a population, you shouldn't be sampling. So for example, if you want to do a content analysis of presidential State of the Union addresses, ask yourself, how many State of the Union addresses are there? There's only one given each year. You can probably analyze every single State of the Union, which means you can do the entire population. You don't have to sample from that. So don't sample if you don't have to. Here's another example. If you are interested in coding the media for, media bias, do you have to sample? Yes, you do. The media is way too big for you to actually analyze all of it. Okay, so if you don't have to sample, don't do it. But if you do, then you go to step 3. And step 3 is to choose an appropriate sampling method. If we don't choose an appropriate sampling method, so if you do it incorrectly or incompletely, your sample is not going to represent the population that you're interested in. And if that happens, the inferences that you draw will be inaccurate. That's what happened with the Literary Digest magazine. They had a sample that was biased towards wealthier people, which means it was unrepresentative of the population. So let's talk about how to sample appropriately. There's lots of different ways to sample for different scenarios. There's 2 major types of samples. The first is a probability sample. This is a sample that uses some type of random selection. That's the word I want you to think of. Random selection or something close to it. And what that means is that each unit has the same probability of being selected. And then we have non-probability samples. These do not use some type of random selection. They use something else. We'll talk about those in the next video. Probability sampling is preferred if we can do it, because randomness means that we're going to have more representation of our population, but sometimes it's not possible. So for the rest of this video, I'm just going to talk about a couple types of probability samples. So the first type of probability sample that uses some type of randomness is the most common one, called simple random sample. In this sample, each unit That could be a person, it could be a news article, it could be a Supreme Court ruling, whatever it is you're sampling has an equal chance of being selected. This is typically what Gallup does when it does polling. They do something called random digit dialing, where they have a computer randomly dial numbers for a telephone number, and that means every single person in the country has an equal chance of being targeted because it's random. So you would do this if you want to do something regarding public opinion, right? If you want to know the president's approval numbers, your population is the whole country, you're going to do a simple random sample of the country to get a representative answer on his approval. So simple random sample. You can do this if you have a full list of people. So say you have a full list of everyone at the College of Charleston, and you have their contact information. You could do a simple random sample by calling random people at the College of Charleston to get a representative sample of your whole population, which is C of C. The second type of probability sample, this is the last one that I'm going to do in this video, is called a systematic sample. This is when you select people from a list or a group at predetermined intervals. So every kth element on a list or a group is selected. So when would you use something like this? This is very useful when you have a large population, but you cannot randomly sample from it. So I want you guys to think about product testing. Here's a picture of a famous I Love Lucy scene. Let's say that you're at a conveyor belt and you're testing chocolates, or you're testing a toy to see if it's in proper shape for it to go out and be sold into the mass public. It's your job to check if that product is defective or not. But there's lots of products coming down the conveyor belt at lightning speed. You can't pick up every single one to test every single one. So what do? You say, I'm gonna pick up every 8th object that comes down the conveyor belt. I'm gonna check it to see if it's defective or if it's good to go. And then I'll put it back, and then I'll wait and I'll find the 8th one after that and the 8th one after that. So you choose a number, some sort of, usually a number between 1 and 10 typically, and you just wait for the 10th item each time to come by. And that's what we mean by a systematic sample. So this is also used in politics in a number of situations. So for example, if you're doing exit polling, right? If you're standing outside of a polling place after people have voted and you want to ask them survey questions about who they voted for, what their demographics are, you can't ask every single person that's coming out of the polling place. It's just impossible. But you also don't want to approach people subjectively, because what happens then? If you approach people subjectively, suddenly you might gravitate towards people that look friendly, that you think might want to take your survey. If you're gravitating towards people that look friendly, they might be a certain type of person. Maybe they're more likely to have your partisanship or your belief system, right? These are subconscious biases that we have. Maybe you don't want to approach someone because they have kids with them and you think that they're busy and, you know, they have things going on. Well, it turns out maybe people that have kids also have other characteristics about them that are the same. Maybe people with kids have higher income levels, and people with higher income levels are more likely to vote a certain way. So you can't approach people subjectively on your own. You also can't have them come to you, because that's also going to bias your sample. Maybe people that are approaching you are more outgoing, or maybe they have stronger opinions and they just want to get their voice heard in your survey. So you can't approach them and they can't approach you, but you can't fully randomly sample them. You can't randomly sample people that are walking out of an exit poll, but You can do the systematic sample. You wait at the door. You say, I'm going to approach every third person, no ifs, ands, or buts. So you set up that sampling frame in advance. And so every third person, that's who you're approaching. That should eliminate some of the systematic bias that could go on in that exit poll. So that's what a systematic sample would do. Choose a number, every fifth person, every fourth person, and that's who you're going to talk to. Okay, so that's the end of sampling video number 1, where we just talk about probability samples that have randomness or some form of pseudo randomness. I told you guys that I was going to do one fun thing in every video. So here's the first one. Because you guys are in my house, basically, I thought I would show you what I consider to be the weirdest thing that I own in my house. So here we go. This is a ceramic clown. Hopefully there's no clown phobias out there in the class, but this is this weird sort of giant ceramic clown, and his eyes are crossed out. It looks like he's dead. I'm thinking, why the hell does my professor own this? Well, last year I was in Brooklyn with some friends, and we saw signs for a stoop sale, or basically the equivalent of a garage sale. So we had nothing else to do, and we were like, oh, let's go. Maybe we'll find some cool random stuff there. So we go into this person's home. All the stuff is being sold in their brownstone in Brooklyn. And we step into the house, and this is what we see. This house is filled to capacity with ceramic clowns. It is one of the creepiest things I've ever seen. They are all over the floor, all over the couches. There's pictures of them. They're coming out of drawers. They're on top of cabinets. Here's more pictures. And this guy's father had collected clowns, and he had died, and he was selling all of the clowns for like $3 each. They were just everywhere. So we were so sufficiently creeped out by this, we didn't know what to do. So obviously we bought one because we had to commemorate the experience, this incredibly disturbing experience. By the way, the house also looks like it's straight out of the 1970s, which is not helping the environment here. But I bought this one. His name is Willie. He came with a name, and I had to have a token of that very strange moment in my life where I went into a house filled entirely with clowns. So that is your one weird, fun thing in this video. Now you've looked into my strange life a little bit. So I hope you guys enjoyed that. I'll do other fun things at the end of the other videos. So goodbye for now.